Hello, sir. My name is Nandini. Today I am going to explain about the topic aircraft electrical power distribution system protection using smart circuit breaker. In some aircraft with the traditional distribution electrical systems, the sources distribution and electrical loads are fully coupled. The control surfaces in traditional aircraft are based on cables and hydraulic actuators. Furthermore, the system stability mainly related to the hydraulic system, and a small portion of it is related to the electrical system reliability. However, for aircraft like A380 and B787, the flight system is based on fly-by-wire FPW technology, and more electrical craft MEA have drawn the attention of aircraft designers. In addition, more hydraulic actuators change to the electrical actuator, which leads to more electrical generation usage. Availability of electrical energy to the loads is only ensured through over-design, system reconfiguration, and protection. Power electronic converters are starting to be used to fully uncouple the dynamics between sources, distribution system, and loads. Aircraft electrical system topology. Significant challenges arise in the design and verification of modern large-scale cyber-physical systems. Such systems comprising a network of sensors, actuators, and physical systems involve integration of computation, networking, and dynamical process equipped with both computing and communication functionalities. Design considerations need to include such aspects as link temporal scales in underlining dynamics, information flow between agents, and coordination of behavior between agents. Or operational situations. Applications of cyber physical systems appear in diverse areas, including autonomous aircraft and vehicles, traffic monitoring and control, energy smart systems, manufacturing, and healthcare. The broad range of concerns. Most of these applications include intended behavior, reliability, survivability, security, and constrained energy availability. While progress has been made in the design of large-scale cyber physical systems within the past few years, there is still a lack of formal design methodologies and technologies capable of providing guarantees on behavior and execution. Consider the application area of modern aircraft avionics. Electronics applied to aviation. Correctly designing such systems significant delays in delivery of advanced aircraft, both civil and military, have been used to unforeseen interactions between large numbers of strongly interdependent heterogeneous subsystems. Advances in electronics technology have made the transition from conventional to more electric aircraft MEA architecture possible. More electric aircraft architectures provide improvements in reliability and maintainability, as well as the potential to reduce aircraft weight and volume. Concept of electrical aircraft is not new, though considered by military aircraft designers since the 1940s. The idea was A comparison between the electrical generation and the distribution on a traditional aircraft type on the Boeing 787 were implemented due to lack of electrical power generation capabilities at the time, as well as volume of required power conditioning equipment. Conventional architectures utilize a combination of mechanical, hydraulic, electric, and pneumatics subsystem. The move towards more electric aircraft increases efficiency by reducing power takeoffs from the engines that would otherwise be needed to run hydraulic and pneumatic components. Moreover, use of electric systems provides opportunities for system level performance optimization and decreases life cycle cost. These architectures also introduce, however, new electric networks and solutions for integrating additional subsystems. Electric power systems. The standard electrical power systems for a passenger aircraft comprises a certain number of generators, one or two on the left and right sides of the aircraft that serve as primary power sources. Generators supply power to a set of loads through dedicated AC buses. Typically, each AC bus delivers power to a DC bus, a transformer, rectifier unit. Contactors are high power switches that can control the flow of power by reconfiguring the topology of the electric power system and establish connections between components. In the case of generator or switch failure, an auxiliary power unit APU or battery may be used to power buses through a different reconfiguration of system components. Different reconfigurations of these systems will change the open or closed status of contactors and thereby affect the power level of different buses or loads. The topologies, structure arrangement of components for electric power systems are already complex. Next generation aircrafts are expected to become even more complicated and thus more difficult to design. The move from pneumatic and hydraulic powdered powered systems to electric powered ones increase the safety criticality of the electric power system. This elevated level of criticality can potentially be compensated but by increasing the number of paths between generator and buses that supply a deliver power to newly introduced loads. The increased number of overall components in the electric power system raises the complexity of design as possibilities needed to be considered. The number of configurations equally goes beyond correctly available verification and testing capabilities. Electric power system schematic includes a combination of generators, contactors, buses, and loads, transformers, and rectifier units. The following is a brief description of the components differenced in the primary power distribution single line diagram. Generators. AC generators can operate at either high voltages, which can connect to the high voltage of AC buses, or low voltages, which feed directly to the low voltage buses. High voltage and low voltage AC and DC buses deliver power to a number of sub-buses loads. Power conversion equipment. Depending on the power availability and quality requirements on the loads, these buses can be classified as the essential or non-essential. For example, essential buses supply loads that should always remain powdered, such as flight accommodation subsystems, while non-essential buses have loads that may shed in the case of fault failure such as lighting. Contactors are high-power electronic switches that connect the flow of power. Contactors can configure switch between component groups. Contactors provides the by the computation for reconfiguration topology in the following list details the temporal logic specifications that typically exist in the synthesis of control protocols. G represents the set of all generators in the electric power system topology. Let the Boolean variable G denote the health status of generator G to G. That is, the lower cases symbol represents the health status of generator denoted by the corresponding uppercase symbol. We use it between the uppercase and lowercase symbols in the remainder of the appeal. Thus, environment assumption status that at least one generator must be healthy, have a state of 1 in any given time. This is written as